Hello, Pre-Calculus kids. This is Mrs. Wenner, and we are ready to start this second to the last section that we're going to cover. This one is section 12.2 on the law of cosines. We talked last time for the last section about the law of sines. Now we're talking law of cosines, and here's the difference. This is the mastery check, but I'm going to flip it over to the blank side and tell you a little bit about the law of cosines. So this is all still how do you solve a triangle for the angles and for the sides when it's not a right triangle. Right triangles are all the ones that deal with sines, cosine, tangents, and such with the trig functions. This is when you have a triangle that is not a right triangle. How do you find the sides? So it's kind of cool. You've got a triangle, we're going to call it triangle ABC, just like we did in the last section. Opposite angle A is little a, opposite angle B is little b, and opposite angle C is little c. And so there's two different things that actually the law of cosines helps you do. The first thing is to find a side. To find a side. So say I want to know what A is. If I want to know what A is, if that's my unknown, but yet I know what B and C are, and I know what angle A is, then here's how I do it. Here's what the formula says. A squared equals B squared plus C squared, the other two sides, minus 2 times B times C, these two letters, and then it's times the cosine of angle A, whatever this is you're trying to solve for, the capital of that. But just like, do you remember those Pythagorean identities that we did with sine squared plus cosine squared equals 1, and then we adapted them for the 3 different ways you could actually see it? Same thing we're going to do with this. So say you didn't want to find A, you wanted to find B. So say you wanted to find B squared. Sorry, the wind is blowing my papers. Hold on. All right, so say you want to find B squared. Then it's going to be the two other letters, A squared plus C squared, minus 2 times A times C, these two letters, but then it's going to be times the cosine of capital B. Same thing with C. You probably can get the format now, right? C squared equals, this is going to be A squared plus B squared minus 2AB cosine of C. And so they're the 3 formats that you're going to be able to use to find a side in one of these triangles. Again, when you get these answers, then you're going to square root it to get what actually A is. Remember, when you square root, it's plus or minus, but obviously this is talking about the length of a side in a triangle, so you're just going to think about the positive part of that. So that's one part of the law of cosines. But say you wanted to find an angle. To find an angle. What if you needed one of the capital letters? You can also use the law of cosines to do that, and really what you're doing is you're taking and you're solving for the cosine of A. So if I took this crazy equation and solved it for the cosine of A, here's what it would look like. The cosine of angle A equals B squared plus C squared minus A squared, because see it's on the other side of the equation, divided by what's in front of this, 2 times B times C. And again, I can adapt that in the 3 ways to find the 3 different formulas to find angle A, angle B, or angle C. So if I say the cosine of angle B, then I want A squared plus C squared minus B squared all over 2 times A times C. All right, if I go to, again, the wind's blowing me. Gotta close my window. All right, then if I go for angle C, cosine of C equals A squared plus B squared minus C squared divided by 2 times A times B. And so all of those are the possible equations that we're going to use to apply the law of cosines. And you'll see the difference of what you'll know when you see the pictures, when you're going to need to use the law of sines and when you're going to need to use the law of cosines, and it depends on what they give you. All right, so let's flip over to the mastery check problems and see how they go. All right, first one. By the way, there are no, at least in the problems that I've done with this, they haven't given us any that are not possible. We're going to see all ones that are possible. I know the law of sines that we did just previously, there were some that were possible, some that were not possible, and there were also some where you had 2 different answers. Those 2 different answers, ones were called the ambiguous case. I don't know if I used that word in the first video. But they're ambiguous because you don't know if it's the first angle or the second angle, and you have to do case 1 and case 2. You don't have to do that with this section in the law of cosines. I'll show you why when we get to the problems. But anyway, so these are all going to work out to a single solution. If I look at triangle RST, I always like the picture. The picture helps me know whether I'm going to use the law of sines or the law of cosines. This is R, this is S, this is T. Again, you can set it up any way you want. I tend to go in alphabetical order. Little s is 33, opposite s. Little t is 24, opposite t. And little angle r is 48. And so when you look at this in this unit, law of sines, law of cosines, you know that you can't use the law of sines if you think about it. Think logically. In order to use the law of sines, they had to have given you an angle, and they had to have given you a pair, like the opposite side. So in this case, they told you a little something about S, they told you a little something about T, and they told you a little something about angle R. They did not give you two things about the same letter. And so that's what makes this section different than the law of sines. You can't apply the law of sines in this. It's not going to work because you don't have two pieces about that particular letter. So what do you do now? So I'm looking at this and I can figure out what my little r is over here. And I can do that because I know what little s is and what little t is, and I have the angle r. So it's going to fit perfectly for the formula. Here's how it works. R squared equals, now this is the same thing that I had on the flip side. I take the side that I want, I take the other two sides, s squared plus t squared, and then I subtract away 2 times s times t, those two letters, and then it's times the cosine of my angle r, which is 48. Well, I'll put a capital R there. Let's fill in all the pieces. I don't know r squared, I'm looking for that. All right, equals. I have s is 33. I have t is 24. 2 times 33 times 24 times, can I fit it in? The cosine of 48. That is one big long formula. But here's the story. If you go to your calculator, make sure your calculator mode is in degrees, which I believe mine is. I'll double check. Yep. Okay, so I'm putting in all this crazy stuff. Let's see if the calculator will handle it. 33 squared. And then I have plus 24 squared. Then I have minus 2 times 33 times 24 times the cosine of 48. And it pops out 605. There you go. So you got r squared equals 605.1. We'll round it. But that's what r squared is. I want to know what the square root of that is. There's a couple ways I can get a square root. Obviously, you can go to your square root button. But if you already have this in your calculator and you want to take the square root, I think we've talked about that before, that you can raise it to the 1/2 power. Taking a square root is the same thing as raising it to the 1/2 power. So what I tend to do is take that answer with the caret and put it to the 0.5 power, and that tells me the answer without me having to go back and put it all into the square root. So just a shortcut if you want it. So here we go. My answer for r is 24.6. We're going to round that to. All right, now I have all of the sides in my triangle. So I'm going to erase my little r that was there because I know that that one is equivalent to 24.6. I've got all the sides. Now I need to figure out the angles. And so what I'm going to do to figure out the angles is, now let's apply one of the, actually now you could use the law of sines because now you know two things about r. So you could use the law of sines that we learned in the last section, but we're going to keep it consistent with the law of cosines for this particular problem. I end up with the cosine, let's go with s, cosine of s equals, and I'm looking at the same idea as what I did on the flip side, cosine of a in this case, so s. I use the other two letters minus my s, and I square them. Okay, so that's how I'm going to set it up, same way. So here it is. I have S, so I'm going to use 24 plus 24.6 squared minus my S, 33 squared, all over 2 times these guys, 24 and 24.6. And so I go to my handy dandy calculator again, and I want to know what this value is going to be. So I have 24 squared plus, I have 24.6 squared, I subtract away 33 squared, I'm going to put an equals in there, not that I have to, but then I'm dividing that by, I'm going to use parentheses, 2 times 24 times 24.6. That whole thing is what I want to divide by. And it gives me 0.078. All right, equals 0.078. And so I want to know what the cosine to the -1 of 0.078 is to get that reference angle. So again, I'm back at the calculator, second cosine 0.078, and it pops out an 85.5. All right, so this is 85.5 degrees. If I go back and think about, all students take calculus, I'll put it up here, all students take calculus, where the cosine is positive in the first quadrant and in the fourth quadrant. Well, in the first quadrant it equals the same thing, 85.5. In the fourth quadrant it would be 360 minus 85. Now if I were to do 360 minus 85.5, I get 274.5. Well, obviously that can't be part of my triangle. It's way too big. And so what I'm going to do is cancel that guy out. My only answer for angle S is 85.5. 85.5. Can you then figure out what angle T is, because that's the last angle I have in my triangle? And the answer is yeah, because we know a triangle adds up to 180. So I take away the 48, I take away the 85.5, and I finally get an answer of angle T being 46.5 degrees. And you have just solved that triangle. You found little r to be 24.6. Actually, that should be kilometers, right? We should put the units with it. And we found angle S to be 85.5 and angle T to be 46.5. And there it is. You just solved that triangle using the law of cosines. All right, let's try another. So I'm over here. I'm going to draw my triangle XYZ. Little x is 16.4. Little z is 14. And little y is 23.8. So in other words, this time they gave me all of the sides and they didn't give me any of the angles. And again, the law of sines would not apply to this question because they didn't give me 2 pieces of information about one letter. They gave me one thing for each letter. And so in this case, I can choose whatever angle I want to choose to try to find first. I'm going to go with angle x just because of alphabetical order. So the cosine of x equals, you take the 2 sides next to it, 23.8 squared, 14 squared, and you subtract away the one that's opposite. And then divide that by 2 times the first two, 23.8 and 14. All right, so I go through my calculator, and I'm not going to show you all the work because I just showed you for the last one, but it comes out to be 0.741. And so you go to your calculator and you do a cosine to the -1 of 0.741, and you get a reference angle that is 42.2 degrees. You would also put that in the fourth quadrant. Can't be, it'll be too big. So your answer for angle X is 42.2. Now that tells you this guy here, 42.2 degrees, but you still need to find angles Y and Z. At this point you have choices because you could actually use the law of sines now because you know 2 things about X. So you can go back if you want to and use what we learned in the first section. It does not matter how you solve the triangle, what method you use, what formula you use, whether it be law of sines or law of cosines, you're still just trying to solve the triangle for all the angles and sides. All right, so I'm going to go with, since we're in law of cosines, we'll stick with it. Cosine of y, now I'm at y, so I want the 2 next to it that make angle y, they're the first 2 I start with. 14 squared, 16.4 squared, I subtract its opposite, 23.8 squared, and then I divide by 2 times 14 times 16.4. This time I get a negative 0.221. Now, if I go back to all students take calculus, I'm going to figure out what this reference angle is. Remember, when you put the reference angle in, you're putting it in as a positive, so 0.221. And that will give me a reference angle of 77.2. But I want to know where it's negative. And so where it's negative, positive here, it would be negative in the second, and it would be negative in the third. So this angle has to go into the second quadrant and the third quadrant. In the second quadrant, it's 180 minus 77.2, and in the third quadrant, it'll be 180 plus 77.2. This will be 150 something, or 250 something. That's going to be way too big, so this one's too big. You can eliminate it. But this one, if I do 180 minus 77.2, I get 102.8. And that is going to be my answer for angle Y. Let me come down this way. So angle Y is 102.8. And then I still need to figure out what angle Z is. Well, angle Z is going to be, if this guy here is angle Y 102.8, then I'm going to subtract them off from 180 degrees, and that's going to give me angle Z. So if I do that work, it comes out to be an even number 35 degrees. And you've just solved that triangle. So we've got angle X was 42.2, angle Y was 102.8, and angle Z was 35. All right, we got one more to go in the intro, and that's this guy. So this one says, again, solve the triangle. Round your answer to the nearest tenth or so. We're going to keep it in the same neighborhood, tenth or hundredth or whatever, or even the nearest whole number, depending on what it is. All right, so looking at this triangle, again, the law of sines would not apply because I do not know two things about one letter. So I've got all the sides solved. Now I need to figure out the angles. I'm going to go with angle A, alphabetical order. A is here. I start with the two sides that make angle A. 15 squared plus 17 squared minus the opposite one, 28 squared, divided by 2 times the first two, 15 and 17. And so I go to my calculator and I toss this all in and figure out what the decimal point is. It's going to be a negative 0.529. So I take the cosine to the negative 1 of 0.529, gives me the reference angle of 58 degrees. But I want where it's negative, so that's going to be in the second quadrant or the third quadrant. But remember, the third quadrant is going to be too big, so you don't have to do that. It's just in the second quadrant. So I take 180, I take away 58, and that gives me 122 degrees. That's going to be angle A, 122 degrees. But I still need to figure out one of the other angles. So again, because of alphabetical order, I'm going to keep going, and I'm going to figure out what angle B is. I'll come over here. Cosine of B. Here's B. The two angles, or two sides that make angle B, are 15 and 28. So 15 squared, 28 squared, minus its opposite, 17 squared, all over 2 times 15 times 28. Get the decimal, cosine of B. So my work comes out to be a 0.857. This one's positive, so I take the cosine negative 1 of 0.857. That gives me a reference angle of 31 degrees. Now, it's positive, cosine's positive in the first and second, but the second wouldn't make sense because it would be 180 minus 31, and that would be like 149. You already have angle A over here at 122. That would be too big. So you got to do what makes sense. This one, it's just going to be angle B is in the first quadrant situation with a 31 degrees. That's this guy here, 31 degrees. And then I can easily figure out angle C without having to go through all the work again, just by taking the fact that the triangle has to add up to be 180 degrees. So I take 180, I take away my 122, I take away my 31, and that tells me that angle C, I'll put it down here, is actually 27 degrees. And so you've got all the sides. You've got angle A, angle B, and angle C. And that, my friends, is the law of cosines. All right, so I will next show you some examples from the homework problems. And if you have any questions, as always, shoot me an email. I'll talk to you soon. Bye.